A cubic graph is a graph of a function that has a term in x cubed. We will look at the cubic function formula, how a cube of a number is calculated, cubes of negative numbers, a simple graph of x cubed, a couple of more complex cubic graphs, the two shapes of cubic graphs, and graphs of factorized cubic functions. You will probably have seen the formula for a quadratic equation. It is y equals ax squared plus bx plus c. A cubic equation adds an extra term in x cubed, so the equation is y equals ax cubed plus bx squared plus cx plus d. Here is an example equation. A cubic equation doesn't have to have all four terms. For example, this formula doesn't have an x squared term. The simplest cubic equation only has a term in x cubed. Also remember that the term in x cubed can be negative. For example, in this equation, the cube term is minus 4x cubed. We know that the cube of x is equal to x times x times x. It is easy to calculate the cubes of the first few integers. 1 cubed is 1 times 1 times 1, which of course is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 9 times 3, or 27. What is the cube of a negative number? If we take the value negative x and raise it to the power 3, that is negative x times negative x times negative x. We know that if we multiply two negative numbers together, we get a positive number, because the negatives cancel out. This means we can write the cube as positive x squared times negative x. So negative x raised to the power 3 is the negative of x raised to the power 3. So minus 1 cubed is minus 1, minus 2 cubed is minus 8, and minus 3 cubed is minus 27. As a first example, we will sketch a graph of x cubed. To sketch the graph, we first calculate some points on the graph, then we join them together with a smooth curve. We will calculate points from minus 3 to plus 3 and fill out the table. We know from before that minus 3 cubed is minus 27, minus 2 cubed is minus 8, minus 1 cubed is minus 1, and 0 cubed is 0. The values for 1, 2 and 3 are just the positive values 1, 8 and 27. We can join these points to show the curve y equals x cubed. The curve always increases as it moves from left to right. Around the origin, the curve changes its slope a little, but it never reverses direction. This is called a point of inflection. Now we will look at a slightly more complex cubic formula. Y equals 4x cubed plus 8x squared minus x minus 2. Again, we will calculate the values and fill in the table. We simply substitute each value of x from minus 3 to plus 3 into the formula and calculate the y values. Once again, we join the points with a smooth curve. This curve has a different shape. It increases as it moves from left to right, except for the region x equals minus 2 to x equals 1, where it dips before increasing again. This curve crosses the x-axis in 3 different places. This final curve has the equation y equals minus x cubed plus 2x squared minus x minus 1. The equation is different to the previous ones because the term in x cubed is negative. Here are the points on the curve. This time the curve starts with high values that decrease as the curve moves to the right. This is due to the x cubed term being negative. To summarise, cubic curves can have two different shapes, an inflected curve or an S-shaped curve. The inflected shape increases in value from left to right, but it has a region of inflection where the slope of the curve changes more rapidly. This curve always crosses the x-axis exactly once, and always crosses the y-axis exactly once. The S-shaped curve also increases from left to right, but it has a region where it dips before increasing again. In this example, the curve crosses the x-axis 3 times. This doesn't always happen. For example, this cubic curve only crosses the x-axis in one place. It is also possible for the curve to just touch the x-axis where it dips, so the curve meets the x-axis in 2 places. Finally, as we saw before, if the term in x cubed is negative, the curve falls as it moves along the x-axis. Every cubic curve follows one of these shapes. It is sometimes possible to factorize a cubic equation. For example, we can factorize this equation: y equals x cubed plus x squared minus 4x minus 4. It can be written as y equals x plus 2 times x plus 1 times x minus 2. If we were to multiply out these 3 terms, we would get the original equation. From this equation we can see that when x is minus 2, the first bracket will be 0, so y will be 0. When x is minus 1, the second bracket will be 0, so y will be 0. When x is 2, the third bracket will be 0, so y will be 0. These are called the roots of the equation. We can see from the graph that the curve crosses the x-axis at those 3 points. If you enjoyed this video, please like and subscribe. You can find more resources at graphicmaths.com. The link is in the description below.